So now we have our data. Let's gonna see what way to look a little bit on this data. Okay, now it's very simple. You saw what is it, but often you import the data, you don't know exactly what there is. I'm increasing here so we can a little bit see more. So one thing is show our data frames, and we can specify to see all the rows and all the columns. Otherwise, show will show only the beginning, the first part and the last part of the data, and how much is first and last part depend on what you're using to visualize. Of course, here we are on Visual Studio Code, so why not to use the tools also provided by the environment. So I click here on Julia, and here on data, I have a data frame. If I click here, I have a nice view of the data frame where I can filter, or I can sort it, so I can analyze my data frames here. Oops. But more in general, except so aside using the tools of Visual Studio Code, we can have this show, and this will work even on the what happened here. It will work also on the terminal. If you want to see only the first few lines, we can specify first. And if you are interested on the last rows, well, last. One important thing is the scribe. The scribe takes some time because it performs a lot of statistics, and it tells us which is the minimum, which is the median, and which is the how many missing we have. So let's gonna do it here on the terminal to see a little bit more. So here for each column, we know which is the mean, which is the minimum, the maximum, or which is the number of missing, and which is the type also. That is an important information on each column. So the first count is a string, the second here is an integer, and then forest area, forest volumes are two floats. We can get the size of the data frame like it would be a matrix with size, number of row and number of columns, and we can get the names using names and returning the vector in terms of strings of the various name of the column. We can iterate over the rows and over the column of the data frames with each row and each column. And here I'm using no missing type to, so here I get, because in this case there are no missing types, so the no missing type is equal to the type itself. But sometimes if there are missing element, we'll see missing in particular, we would have an union of missing and the other type of the column. So here is a short way where we can get in some insights of the data that we are going to use. More in particular, how can we select, how can we query our data? So let's start with column selection, then we'll see row selection, and finally cell selection, and then we'll go to the query part. So in general, we can select by name, a column by name, or we can select a single column or a vector column. And one important thing that need to be understood is that there is one other option that we can choose to select some data making a reference to the data. So if this end up to, we create an object here, AA, and AB. Look the difference here. When I use this exclamation point, I'm making a view of the data. When I'm using the column, I'm making a copy of the data. So the exclamation point is put attention, because if now I'm going to change AA, what I'm going to change as implications will end up to change also our original data frame. While here being a copy, of course, if I change it, I do not influence data. And this is also because, as we saw, when the column operator make copy, so the same as is used for the matrix for an array, here for a data frame, when we specify the column operator, we are doing a copy. So to select a column, we enter as in the row position, either the column to indicate all row or the exclamation point if we want a copy, if we want to make a reference, so basically a view of the data. And then we specify the column that we want, either one or several, or an array of them, or a range also. And we can do that using strings like here, or using the symbol equivalent of the name of the column. So here is a vector of two column. If we want only one column, we can just use the dot operator and chain data frame name dot column name. And attention that this is equivalent to use the exclamation point. So here will be a view of the data, not a copy. Also, we can also get the column by positions, and notice how much more nice than pandas here. We don't need to specify loc or iloc. Just if you use an integer, we are assuming that we are working by position. If otherwise, we are using by name. If you want all the column except a few, you can use the not function, so that here we are getting all the column except here. So here, for what it concerns the selection of whole column, the rows, they don't have a name, so you select the row by position. So here select the first row, and it's the whole row, because here we are using the column operator, and the result will be a data frame row, because it's only one row. So data frame row is an object that still keep information about the various fields, and if it's more than one row, we return another data frame with the row that has been selected. Finally, we can just put these two together and indicate both the row, here the second one, and the column, here by position and here by name. So to summarize, what is returned in these selections are, if you are a single column, we obtain an array. So here, for example, it was an array, and here really tell you that what is inside a data frame is an array. So the columns are actual arrays, are not anything fancy than that. If it is a row, instead we return some object that is called a data frame row that behave very similarly to a data frame. if we are returning a single cell, we get the value of the cell of the type T in depending on which column is the cell. And in all other cases, so when we have multiple column and multiple row, we return another data frame. Now, how do we select data? Well, one way is to use something called the Boolean selection, and I think we already saw this for arrays, so the thing is valid also for general arrays. The idea is to specify the position that we want and differentiate for those that we do not care of by using some Boolean values in the relevant index. False we are not selecting, and true we select them. So our mask here is a vector of 4 false, 2 3 and 4 true. And when I use this syntax, I'm selecting all the rows, all the column, but the rows also only the fourth to the last one. So here I have only the last 4 elements, so the 2020 element. Notice that this Boolean selection here is at the level of a single axis, the array, but we can also have a matrix acting as a Boolean selector. So here I'm starting with negative and then with false, and then for some element I'm putting true, and I end up with this matrix. And unfortunately, you cannot select a data frame with a matrix of bools element, but you can do that for a normal matrix. So I can first transform in a matrix my data frame, and then using Boolean selector over my my matrix to select the element that I want. So why is Boolean selection important? Well, because it can be used to filter based on conditions. So here what we are doing is that we select all the column, and for what it concerns the rows, we put some conditions. So here we ask where the year is higher or equal to 2020, and not the dot here because we are broadcasting, because this is a vector. So this will return in something very similar to this mask. We will tell us where is true, that where this condition is true. So at the end here we will end up with a vector of Boolean values, and we use Boolean selector to extract the information we want. So here again, they are the last four records in the data frame. And same things here, a little bit more complex, but exactly the same. Here we create a Boolean selector where we select first here. So here will be a first vector of Boolean elements turning true, where the individual row is either France or Italy, and then we can make an end statement, an end operator with a logical operator with the factor if the year is equal to 2020. So here is two conditions ended, we will end. So of course the result will be only those rows that are France and Italy, and the year is 2000. So this is already very powerful. You can do everything, I think, with Boolean selection. Although it's not very friendly, as you can see that things can start to become pretty long pretty quickly. So there are some other ways to select, and in particular here we'll use two packages, data frames macro and the query package. The first one export a macro called subset. So here I can write yearly subset data, the data frame, and then I put the conditions. And here again we put several conditions. So here we put here higher than 2010 and a certain column equal to France. And here I made this example because often the column that you want, you don't have the name of the column, but you have the name inside variables, like here call to filter. So call to filter is embed the column that we want to filter. And in order to protect it from to use it in the subset macro, we need to protect using this calls function. So if here would have been country with the symbol here, there would be no problem. It works. But as this is already embedded in a variable call to filter, we need to use calls and the name of the variable that include the variables that we want to use. And here again, of course, the result will be, well, I didn't call to filter. It will be France 2020. The last way I want to show you to filter packages is using the query packages, and this is interesting because although it is a little bit more verbose, it's really become really evident, especially if you have to do a lot of operations here. You can chain them using this syntax here. Use from the from macro, and then you can specify where the conditions. So this is very similar to SQL, structured query language, where you select you first put from, then you put where to filter, and then you specify what you want to select, so which column you want to in the output, and then you collect everything in a data frames, and you get the result that you would expect. And it's very flexible approach. Now, up to now, we worked with a data frame that had all values, so it was dense data frame, all values were known. Very often, you will end up with some missing values. We already saw what missing values are when we had a general discussion on the implementation of missingness, I believe in the very first segment. Let's see which are the tools that data frame provide us to work with missing data. Let's gonna start with copy the data so we don't ruin our original data. And notice that if I want to this is important. If I want to to set some particular data as missing, I would have an error. Why that? Well, because the type here, if I go back to df, you can see here the type. So here is the name. Is a float for area is a float 64. So this column accept only float values. It doesn't it doesn't accept missing. To allow the column to accept missing value, we can call allow missing, the column specific, or more in general, if we want to allow missing everywhere, we can allow missing here the whole data frame. So with this exclamation mark at the end, we imply the version of these functions that change in place the data. So here it is not changing. We have to make this one is what allow for missing value, but it doesn't change the f dot for area here. This is why we need to to use df for area here and here, while here we do in place. So if I call it now df, you can see here but there is also a question mark to indicate that we have the possibility to add the missing. And if I describe df, you will see here that the inner type of each column is a union between missing and the type of the column itself. Now I can put missing, so let me play a little bit and add a little bit of missing value. So if I again plot df, I have some missing here and there. How many? Well, I can use is missing and find all the is missing and count them. So I can get the number of missing in one specific column. Now, how can I get rid? Okay, now I put missing data. Now the question is how I can get rid of this missing data if you know that missing propagates. So what you don't want, you want to keep all the data except the missing one. So the first easy thing is to use drop missing to df. I return a data frame with the row only where there is no missing data. So I'm skipping this row and I'm skipping this row here. I can also skip the row where the missing are on some specific column, like here, and I can get the data of one column without the missing data with the skip missing and followed by collect, and I have the element of the 4 area that are not missing. So here I already get the data frame values without missing. Another option is to use complete case. Complete case return Boolean values. So here is a bit value where of the row where there are no missing, either in the whole data frame or in specific columns. And then of course we can use Boolean selection on this complete case to get the same things as drop missing and return a data frame with non-missing data only. Now what if I want to easily input the missing on with some data? So if we want to impute data, missing data, we will see with machine learning technique a way to impute the missing data to their most likely value. But if we already know that our missing are a certain number, for example, most often we have when missing should be interpreted, but it's up to you. This is the nice thing. It's not the language that tell you this one implicitly. It tells you, the modeler, that know the meaning of missingness in your specific case. So if you, the modeler, know that missing for you is a 0, should be interpreted as a 0. Well, here is a sorry, a quick way to change all missing in and set them equal to 0 for each numerical column. So here we are actually making two loops. The external one is through the column, so we loop through the various columns, and if this column the type of the column is a numerical one, then we are going to asking the broadcasting over all the rows. If it is missing, if this data is, so at this point this specific value on this column and this row is missing, we set it equal to 0, and of course also the equal sign is broadcasted across row. So if I type here df, my two missing values on forest area has been converted to 0. And the same things we can do that for string columns, and actually here should be abstract string. So if there are string column, we replace them with a null string. And here we are.